Alright, so in the previous video we left off by having calculated our means and standard deviations and reformatting the decimal points as required by the IA rubrics. But now I'm going to show you how to graph the means and the standard deviations in a way that will allow you to do some analysis based on these statistics of standard deviation and averages to help you reach a conclusion about whether or not the independent variable that was chosen that is being tested around which you collected data has an effect or not by looking at the data of the dependent variable or the data that you measured. So let's go ahead and start. What I'm going to actually do is I'm going to select these 6 cells, the one that has the label of mean and has labels of before and after and has our 2 average data points. And what I'm going to do then is go to Insert, and in this case I'm going to click Column. You know it is a bar graph. Excel calls it a column. Excel actually calls this a bar graph that goes from left to right. And really that's fine. You could do that, but that is probably not the most appropriate. It's not the easiest for an audience to read. So we go with the column graphs here that we call bar graphs. Now, before I do anything further, let me point out that if you take any of the other IB sciences, usually bar graphs are not acceptable. And we often accept them in biology, except when your independent variable is a concentration gradient, or a time gradient. So if you're measuring things along, your independent variable is time or concentration of a solution or something along those same lines, in fact, you would instead do a scatter plot and then add standard deviation lines on top of that. And I'll show you how to do standard deviation lines on top of a column graph or a bar graph. But it's the same methodology for adding that to a scatter plot. You'll do the same steps. So we're going to do it with a bar graph because that's the easiest thing to see here. And that's what this data is going to be best represented by. So I'm going to click Column, and I want a simple 2D column. I don't want anything fancy, anything that's distracting to the actual data. So this is what you are going to use. Whenever you use a bar graph, you're going to use this first one, a 2D column clustered graph. So we click on that, and out pumps, because we selected these 6 cells, we see that the data that was plotted for before and after is the mean. But what I need to do is, click that too many times. I need a better title. And we'll figure that out together, but I'm just gonna write in better title because this is generic. Depending on your data set, you need to fill in a better, descriptive title. But I'm gonna add plus or minus 1 standard deviation. And I need to indicate that. Now here on the graph we don't have anything that indicates standard deviation yet. We're going to add that. I'm going to go ahead and delete this title because you would actually put that in the title. So not mean better title, but it would be the mean heartbeats per minute before and after exercise. So I've got my heartbeats per minute, and then I've got also at the end of that plus or minus 1 standard deviation. That's going to indicate the error bars that we're going to add here. Now, I'm going to click on the whole graph, and then up here on Chart Tools, I'm going to go to Layout. If you go to Layout, you can add. Here we've got the chart. The title is above the chart, and so that's one thing, but we don't have any axis labels. So if you want to add those axis labels, and I'll say you want to, otherwise you won't get a good score. You'll have to redo it or with a new data set. Go ahead and select your primary vertical axis, which is your x-axis, and then your y-axis, and then your horizontal axis. And that will be, if you click on this, it'll give that to you for your x-axis, and you put in the title. You don't necessarily need a legend for this case, but if you need a legend, this is where you go. We don't need to do data labels or data table because that's right here, right underneath. You can change the way it looks. You can add a trend line. In this case, we don't need a trend line. It's not a scatter plot. But what we are going to do, let me go here real quick. Yep, it's not there. It's here in layout. We need to add our standard deviation error bars. So I'm going to go to error bars over here. Now, it's very easy to say, oh, there it is. That's what I need. Error bars with standard deviation. I'll tell you that's not going to do it for you. Excel doesn't really, selecting this doesn't meet our needs to demonstrate standard deviation for each set of our data. So I'm going to actually go to more error bar options. I'm going to scoot this over so we can see what it does. Now right now you can see that these error bars are about the same size. They actually are exactly the same size because it's set at a fixed value of 10. Well, we know that the standard deviation for before and after are not at 10 and they're not the same. So if we go to custom, well, we want caps on both. We want, above and below, so plus and minus 1 standard deviation. And we need a cap to better see where that line is. So we're selected in the right places here with direction and end style. But we go to custom and specify value. Now this is going to give me positive error value choices and negative error value choices. So if I tell it I want plus 1 standard deviation, well, 1 standard deviation for before is 5.55 and 1 standard deviation above is 8.85 above the averages, right? So I'm going to click on this blue button and select both of these values just like that. And because of the cells that they're in, it knows that it needs to go with those averages that are right above it. Excel is smart in that way, so that's good. We're going to do the same thing for negative. Select the same values and click OK. And there we are. So I'm going to close this, and now here is our graph with plus or minus 1 standard deviation. Now looking at this, we see that it's equidistant around the mean. Plus and minus is the same, so that's good. And they're not the same, so that's a good indicator that that matches up with what we have here in our in our statistical analysis data table. And also looking at this, you see that plus or minus 1 standard deviation for before does not overlap on the y-axis with the plus or minus 1 standard deviation of the after data set. If you don't know what I mean, if you were to take these error bars, move them horizontally all the way to the y-axis, and do the same with this, you would see that they would not overlap. And what that means is that 68% of the data, remember that's what's represented by plus or minus 1 standard deviation, does not overlap with each other. And so according to this, you could say that there is a significant difference between these two data sets at plus or minus 1 standard deviation. But remember, that's 68% of the data. That's not quite good enough. So what you would need to do is actually one of two things. And I would actually recommend both. One to visually see it, and the other is to do a t-test. So if you were to go to these two standard deviation values and actually add another column here that's 2 standard deviations, and multiply this number by 2 and put it here, this number by 2 and put it here, and actually add those two values to the custom error bars, you would see 95% of the data. Remember, 2 standard deviation represents 95% of the data, which is much stronger and meets our criterion that we use in science. So you could do that. I'm not going to do that here because I think you could figure out how to do that. The next video is going to show you how to do a t-test, which is a more conclusive way to figure out if there's significance or not.